Hi, this is what I'll be coding today, except it's going to be animated. The top shape is a regular prism, meaning that it has two regular polygons with all edges and all angles equal as bases, and rectangles as lateral faces connecting the two bases, which you cannot see here because, well, perspective. So let's switch to this sequence where you can see various kinds of prisms that have a base visible. You can't really see both bases at the same time unless you have semi-transparency, so that's that. Let's switch back to the second shape. This one is a regular pyramid, meaning that it has a regular polygon base and identical triangles for the lateral faces. Let's also see a few different kinds of pyramids. These have semi-transparency so that you can see the bases. You can see that these are differentiated by the number of base edges, by height, and by base size. And let me just show you what I mean by base size. I mean the size of this circle on which all the vertices of the base polygon are situated. This is called a circumcircle, and not all polygons have a circumcircle, but all regular ones, like our base polygons, do. And its size is defined by its radius, which is called the circumradius, and is this segment between the center and a vertex. Okay, so our shapes are going to be differentiated by base face circumradius, number of base edges, height relative to that circumradius, and of course the type. We have a prism or a pyramid. I'll be creating and shading these shapes with pure CSS, and by shading I mean that as they rotate, the faces become lighter as they come to the front and then get darker as they return to the back. So the faces that are, well, facing us are always the lightest. So that's kind of like in this demo where you can see the much darker faces in the back through those gaps along the edges. This is a lot more complex than what I'll be doing today, but it's still going to be linked in the description in case you want to check it out. And it does have a quick explanation of what's going on in there, though it might not be enough if you don't have the geometry/mechanics background. But yeah, it's still going to be linked, as well as this one, which is pretty similar. And again, you can see through those gaps that the faces in the back are darker. But now let's switch to actually coding something and putting something on the screen, right? So as we said, our shapes are going to depend on a bunch of parameters. The first one is going to be the circumradius, and we're going to define that in the CSS. So let's say it's going to be something like 5 okay? We might tweak that later. And here we're going to have a shape 3D mixin. And here we're going to consider the circumradius having a relative value of 1. Okay, so everything else is going to be relative to this value of 1 of the circumradius. And then these relative values, we're going to multiply them in the CSS. We're going to pass them as custom properties to the CSS, and we're going to multiply those relative values of the custom properties. We're going to multiply them with this circumradius value from here. Okay, so let's see what we have. We have the number of base edges, and let's say this is going to be 8 by default. Oh, and of course this is going to be a mixin. Silly. Okay, we're going to have a height relative to the circumradius. So we pass a height multiplier here. Let's say it's going to be 2. So the height is going to be twice the circumradius by default. And then we're going to have a type. This is going to be 0 for the prism and 1 for the pyramid. Next up, we're going to compute a base angle. And let me just show you what a base angle is. So it's basically the angle corresponding to one edge. So the angle between this radius and this radius, okay? Now let me just show you a bit here. This angle is obtained by dividing the full circle, 360 degrees, by the number of edges. So in this case we have 6 edges, and we divide 360 by 6, and we get 60, okay? But if we have more, for example, something like this, we divide 360 by 8, and we get 45 degrees. Or we can go somewhere even higher. So for example, if we have 10 vertices or edges, the number of vertices is equal to the number of edges, okay? Then we divide 360 by 10 and we get 36, okay? So this is how it works. This is how we get the base angle. So 360 is equivalent to 2 pi in radians. So over n, this is the base angle. And then let's see how we can get a few other things, a few other regular values. Let's get back here. And other than this circumcircle, we can have another circle, which is called the incircle. And this is the circle that touches every edge at one point, which you can see marked there. Okay? Now, this is called the incircle, and its radius is called the inradius. This inradius both splits the base angle into 2 equal halves, and it also splits the edge into 2 equal halves. And it's also perpendicular onto the edge. Okay? So this triangle formed by the circumradius, the inradius, and half the edge, this is a right triangle. It has a 90-degree angle right there. And since we know this angle because it's half the base angle, which we've already computed, and we know that we use a relative value for the circumradius of 1, this means that we can compute the inradius as being the circumradius 1 multiplied with the cosine of half the base angle, and half this edge is going to be the circumradius 1 multiplied by the sine of half the base angle. So the edge is going to be twice 1 times the sine of half the base angle. So let's put that into code. Relative inradius, okay? This is going to be 1 times cosine of half the base angle, okay? And then we're going to have something very similar, but of course this is going to give us a lot of ugly decimals, and we don't want that. So let's say we're going to do something like that, okay? So here we're going to have something similar for the relative base edge. This is going to be sine, and we're going to have to double it, okay? So now that we've done this, next step is going to be to compute a relative face height. Now, in the case of the prism, this relative face height is going to be equal to the shape height, which we already know is that height multiplier, hm, times 1, okay? Now, in this case, it's going to be a bit more complicated, so let's get here. I think this is the biggest, and it's going to be a bit more clear here. So if we draw a perpendicular from here onto the plane, this perpendicular is going to fall right in the middle of this shape, which is going to be right in the middle of, in the center point of these two circles, which is one and the same for regular polygons, okay? So that height is going to drop right there, and it's going to be perpendicular onto the plane, so perpendicular onto every segment in the plane, including the inradius, which is already perpendicular onto this one. So the height of the lateral face is going to be the hypotenuse in the triangle formed by the pyramid height, the inradius, which is perpendicular onto the edge, and itself, the face height, okay? So you can get the face height as being the hypotenuse in that triangle. So we said the relative inradius is one edge, and then we also have the pyramid height, which is basically that height multiplier times 1, okay? And again, we are going to want to have something like that. Actually, we're not going to round it here. We're going to round it a bit later so that we have the unrounded value here for the computations, okay? And of course, this value is going to depend on the type. So if the type is 1, meaning pyramid is going to be this value, otherwise it's going to be equal to the pyramid height, which is the height multiplier times 1. Then let's say we're going to have something like this, a scene. Within it we're going to have a 3D shape. Okay, I can't type. And within it we're going to have a loop. So for I going from 0 all the way up to n, the number of base edges, increment it at every step, and create a face, and it's going to be a lateral one. And in its style attribute, we'll be setting a rotation progress around the y-axis. So by that I mean this is not rotated at all. This is rotated by 1 over n times a full circle. This is rotated by 2 over n, a full circle, and so on. Okay? So that's basically our progress. So this is going to be I over n. And of course we want to round this value. And also right here we're going to want to set some values as well. So the relative in radius, for example, which is going to be something very similar. Okay, then a relative base edge, and as I said, we're rounding those values here. Okay, and then we're going to have something very similar for the height, relative face height. So now let's start putting some stuff on the screen, even though we're not done with the structure, but just so that we can see something. So for our lateral faces, we're going to have a width, which is going to be that relative base edge value times that circumradius, and then we're going to have something very similar for the height, except we're going to use the relative face height. Okay, now having done this, we're going to set a background just so that we can see stuff. Oh, we haven't called the mixin, that's why we're not seeing anything, of course. Okay. For some reason pressing D is weird. And we're going to have a second one. This one, let's say it's going to have 12 edges. We're going to use a 2.5 multiplier, and it's going to be a pyramid. Now, let's use clip path. No, actually, we're going to set on the face elements. We're going to set a clip path and polygon, and here we're going to have a list of vertices, a list of vertex coordinates. Okay, and here we'll be setting, so this is going to be 50% 0, so the middle of the top edge. Then we're going to have the bottom right corner, which is going to be 100% horizontally, it's at the right, and 100% vertically at the bottom. Okay, then we're going to have left bottom, which is 0 horizontally and 100% vertically because it's at the bottom. Okay, so we have triangles, which is not what we want for the prism, but for now let's leave it at this, and let's take care of some layout stuff. So on the body, on section, and on all the elements, we'll be setting display grid. Now on all the face elements, we'll be setting grid area, first row, first column, so they're all in the cell at the intersection between the first row and the first column. And all div elements place self center. Okay. Now let's set a few things on the body. Margin 0, height full height. Okay, so now you can start seeing something. Let's start setting some transforms here. This is going to be rotate Y, and we're going to have that J progress times 1 turn. So this is okay. Now something else I'm going to want to set. So on the scene, I'm going to want to have perspective, something like 35 ems. And on the 3D shape, transform style, preserve 3D, because we're going to want this to be transformed in 3D. And we don't want its children to get flattened in its plane. So we want their 3D transforms to be preserved. Now translate along the third axis by the in radius. So basically at first all our faces are there in the middle, right? So the middle of their base edge coincides with the center of this, right? And then we want to translate them so that they get here. They get from here to here. So this is basically the base edge of the lateral face. Now let's get back here, and we're going to have this calc relative in radius times that circumradius. Okay, now it's starting to look like something, which is getting exciting. Okay, that's an ugly background. Okay, let's get it out of there and let's put the background on the face. So let's say this is going to be something like linear gradient, of course. Linear gradient, deep pink, gold, something like that. Let's make it 0 degrees. So something like that. Let's actually set here opacity 0.5, just so that we can see a bit of the 3D. Now the next step for the pyramid is going to be to rotate these lateral faces around their base, around the midpoint of their base. So that's going to be transform origin, middle horizontally 50%, bottom means 100%. Okay? So we're going to have a rotate X, let's say something like 30 degrees. This is a pretty random value and we're going to change it later, but yeah, just so that you can see. And this is going to happen only for this. We're not going to do it for the prism, but a bit more on that later. So let's compute that rotation angle. So the rotation around the x-axis, again, this is going to depend on the type, and it's going to be one value here if we have a pyramid, and if we don't have a pyramid, if we have a prism, the value is going to be 0. Okay, which is why we should also pass the type here. Okay, so the type, we should also pass it to the CSS. Okay, now let's go back here. The angle of the lateral face with the vertical is the angle of the lateral face with the pyramid height. So that's the height of the face height with the pyramid height. And we already said that we have a right triangle that's formed by the pyramid height, the in radius, and the lateral face height. So that angle is basically going to be arctangent of the in radius over the pyramid height. Okay, so this is going to be okay, and we want it in degrees, so we multiply with 180 and divide by pi, and of course we're going to want to round this. So now that we've done this, let's so it's going to be very similar. So it's going to be degrees. So now, okay, that looks weird, that kind of spacing. Oh, typing is not my strong point, definitely. Yeah, I messed that up. Okay, hopefully I've fixed it now. So let's get back here, and we're going to have a rotate, and we're going to use that angle. Okay, much better. Now let's fix this. So we don't want triangles for these faces, okay? So to do that, we're going to have here type which is 0 for the prism and 1 for the pyramid, okay? So you see that first point goes to the top left corner, and we're going to want to add another point which is going to be either in the middle for the pyramid, so type being 1, or in the top right corner for the prism. Okay, so that's going to be 100% minus that. So if the type is 0, this is going to be 100%. So it's going to be top right corner. And if type is going to be 1, then this is going to be 100% minus 50%, 50%, which is going to be middle top, okay? Like the prism case, like the pyramid case. So this is a prism, this is pyramid. Prism is type 0, pyramid is type 1. Okay, just in case I somehow said that wrong. I don't even remember. Okay, so one more tiny thing here, because I don't really like, I have those gaps there. Should I increase this? Maybe I'm not going to have those gaps if I use something a bit more precise. No, I'm afraid that's a browser thing. So let's try a different kind of fix. So scale X, something like this. Not quite, might be too much. Okay, this is better. I'm just going to leave it like this. So this is basically a browser error correction sort of thing. Yeah, not quite ideal. Anyway, let's get back to the structure and generate the base faces. Okay, so we're going to have a number of base faces. And this is going to be 2 for the prism and 1 for the pyramid. So that's going to be 2 minus the type. So now here, number, okay, and here we're going to have a k value, and this is going to be 1 minus I. And next up, we're going to generate a list of vertex coordinates. So, of course, these are not going to be lateral, they're going to be base faces. So we're going to have a list of vertex coordinates, and here we're going to have an offset angle. Now the thing is, let's go back here a bit. We're getting something for a shape like a triangle, or let's go back, a pentagon. Okay, you can see that these shapes start from here, and the opposite direction, they have an edge. So they have an edge opposing the first vertex, okay? Now, what we're going to want is rotate this from 3 o'clock to 12 o'clock. So rotate it by minus 90 degrees or minus pi over 2. However, for something like a hexagon, we're going to want this sort of positioning where the first vertex is there. So it's not at 12 o'clock, which we said is a rotation, minus 90 degree rotation. We actually go there, minus 90 degrees, and then we go back by half the base angle. So what we're going to have is minus half of pi and then plus half the base angle if the number of edges is even. Okay, so that's going to be 0.5 times, so if n minus 1 modulo 2 times the base angle minus pi. Okay, this is going to be the offset angle, and then we're going to have a loop. So the offset angle is going to be the angle of the first polygon point, which for these shapes with an even number of edges is going to be half a base angle away from 12 o'clock or minus 90 degrees. Okay, so having done that, let's bring that loop here, and within it we're going to have the current angle is going to be the offset angle plus I times the base angle. Okay, and then we're going to push to this list of vertices, the array of vertex coordinates. Now let's go back here. This circle is going to be contained in a square of edge equal to the diameter. So this is going to be contained in a square whose edge is going to be equal to the diameter of the circumradius. Okay, so this is going to be the 50% point of that square, and all these points are going to be defined relatively in percentages. The coordinates of these points are going to be the offset coordinate of the center, which is going to be 50%, plus the radius times the angle. Now the radius is going to be 50%, because obviously, okay, times the cosine of the angle for the x-coordinate times the sine of the angle for the y-coordinate. So we're going to have 50%, sorry, we can't use percentages there, 1 plus cosine of the current angle, and then we're going to have something similar, sine. Okay, now having done this, we're going to go outside the loop, and this list of vertex coordinates, we're going to map it so that we have every pair of coordinates. Okay, and we map this such that every coordinate becomes a percentage value, and of course we're going to have some rounding here. And this should be enough, I believe. And of course this is going to be a percentage value, and then we're going to join these with a space because that's what we need for clip path. Okay, so then we're going to have here, and now for these base faces we're going to have padding equal to the circumradius. Okay, so you can see that we have them right there. Then we're going to have transform, rotate. This is going to be calc, let's say 1 minus 2 times k times 90 degrees. Sorry, rotate x. Okay, and then we're going to have a translation. So now you can't really see them because they're in the mid plane, and you see them from the side, and their thickness is basically 0. So, but if we translate them, then and we're going to translate them by half that height. Okay, you see them there, right there. And here, this is going to be interesting. So we're going to use calc, and k times 100%. But k is not defined for the lateral faces, okay? So we're going to use 0, a fallback of 0 for the first one, and a fallback of 1 for the second one. So we get that result that we wanted. Okay, and let's actually have this opacity 0.5. Let's have it on all the faces, because it makes a bit more sense like that. And next up, let's set an animation. So keyframes, a rotation around the y-axis. We're going to go to transform, rotate y 1 turn. Now, having done this, let's we're going to want to set an animation duration. Let's say it's going to be something like 12 seconds. Okay, so set that here. Animation, linear, infinite. Okay, so having done this, you can kind of see it, but not so much. But you're going to see it in a moment. Now, for these lateral faces, we're going to have another animation. This is going to be a shade animation, and this is going to use filter, brightness, and we're going to set a brightness value. Okay, let's get up here and set a brightness value 0.2, for example. Okay, and this is going to be ease in out. We're going to use half that animation duration, because we want light when it's in the front and the darkest is 0.2 brightness when it gets to the back. So it's going to be 0.5. So half it takes for the rotation. So we're going to go from light to dark in the back, and for the first half of the rotation, and then we're going to go from dark back to light for the second half of the rotation. So it's going to be half the animation duration there. And of course, alternate. And here we're going to have a delay, and we're going to use the same progress of the rotation there, J, times minus the full rotation animation duration, and you should now see it. Okay, it's a bit more visible if we comment out that opacity. Right? Now, I wanted to keep that opacity a bit to show you something, because I want to have a filter, for example here, brightness, and I'm going to use here calc. So let's say I'm going to have 1 minus that minimum brightness times 1 minus 0.5 times k, let's say that. Okay, so you can see now, so for example, if I set display none here, this should make it a bit more clear. Let's get rid of that not there. Okay. So something like that. Yeah, actually I think it's pretty good, because it has 0.8 brightness there, and this is going to be 0.2. But I do wonder. Now I'm just going to leave it like that, because it's slightly darker than the lightest one here, but it's still a lot lighter than most of the lateral faces. I'm going to leave it like this. Okay, so let's get rid of that. Let's get rid of that display none. And let's add a few prettifying tweaks. So let's say, for example, we're going to have background here. I don't even know. Something like this. Now for the scene, let's say something like that. Let's use box shadow, 2 pixels, 2 pixels, 5 pixels. Let's also set something like a gap. So, or spacing, or whatever you want to call it, 1em, and set it here, grid gap, and then also padding equal to that gap. And of course, let's get rid of that scroll bar with box sizing, border box. That should do it. So yeah, this is it. This is what I wanted to show you for today. I hope you've enjoyed this video, and if you like the work that I'm putting out for almost 9 years now, please consider supporting it so I can continue in the future. You can do so by being a cool cat and becoming a patron on Patreon, and huge thanks to everybody who has already done that. Or you can get me something off my Amazon wish list. Again, the links are going to be in the description, just like for the Patreon thing. Or you can at least share this to show the world what can be done with CSS these days, because honestly I think it's pretty damn cool. In any event, thanks for watching, and until next time, bye.